on to page 2 of this test. Just some more antiderivatives, and I don't know, this one shouldn't be that hard, but it does look super complicated. You know, I see the 6x cubed plus 5 as an input, and I'm thinking u substitution. And so I guess the first thing I want to do to make my life a little bit easier is just rewrite this with the 5x over 2, the 5 over 2 out of the way. 6x cubed plus 5 gets a new exponent of 1/4, or gets the same exponent in a new view. And so if I am going to do u substitution, let's see, what am I going to do? If I take the derivative of 6x cubed, I get 18x squared. So I can just go ahead and put those in ahead of time. Yeah, I think that's good to go. Yeah, I don't know. Maybe I feel something in my brain doesn't feel right, so maybe I'll just do the u substitution instead. Okay. So u is 6x cubed plus 5. du is 18x squared dx. No, that's exactly right. I don't know why I couldn't handle that. Weird. Okay, so that's going to be 5 over 36. Oh, that's why. I knew there was something weird in my brain, but that's because of the antiderivative stuff. So that's just going to be u to the 1/4 du. Do we have everything? We do. Okay. I think plenty of people missed this because they did not get the new exponent 5/4 correct. And because of that, we're going to multiply by 4/5, the reciprocal. Okay, so that's 1/9. And we want to make it look pretty, so we will do the 4th root of 6x cubed plus 5, all raised to the 5th power, plus c. I think that looks pretty. Another one that's going to be relatively straightforward if you rewrite. You don't need anything special here, just power rule. So let's rewrite this as x to the power negative 4/3. I think there were some people that I think just got the exponent wrong. I kind of forget. So we're going to have x to the power negative 1/3, and we'll multiply by negative 3. Because the chain rule on x to the negative 1/3 would be negative 3. Oh, negative 1/3 times negative 3. Yeah, there we go. So negative 15 over the cube root of x plus c. I'll skip that for a second. So here, I thought it was pretty obvious. The easiest way to do this one would be to multiply everything out. But some people thought you could just do things in place, getting stressed out, not really sure. So take your time with the algebra. So let's see, that's going to be 8x squared plus 10x plus 4x plus 5, all dx, and then I'll rewrite that as 8x cubed plus 14x squared. Quite a few people left the 10 and the 4 separate, which, you know, whatever, doesn't matter, all good. So antiderivative of x cubed is x to the 4th, so 2x to the 4th, and then 14/3 x cubed, 5/2 x squared, plus c. Pretty straightforward. One more or two more? Two more. I'll come back to that one because we'll just keep doing algebra here. And then again, I thought this was pretty straightforward because you have 4 terms in the numerator and that x cubed in the denominator. We're just going to divide term by term to get some relatively straightforward antiderivative. So 15x to the 4th over x cubed is 15x. Negative 2x cubed over x cubed is negative 2. 3x squared over x cubed is 3 over x. We've seen that antiderivative before. And then I'm actually going to write that as 2x to the negative 3, just thinking ahead. Then I'm going to be doing power rule. X squared over 2 is the antiderivative of x. Antiderivative of a negative 2 is going to be negative 2x. 3 over x has an antiderivative 3 natural log of the absolute value of x. And let's see, we're going to add 1, so that's going to be x to the power negative 2 is the new exponent. I'm going to multiply by negative 2, so I need a negative 1 out front. Yep, okay, feeling good. I don't really feel like rewriting negative x to the negative 2. We're fine. Okay, so the last one, hopefully you recognize that you can't use substitution. And apparently I can't zoom in anymore. Super weird. That's the maximum zoom in. So weird. Okay, well, whatever. You can't use substitution because we don't have that x. You're supposed to recognize that this is the derivative of inverse sine. Well, I guess it could be inverse cosine, but why not do inverse sine? So I'll pull that 5 out, 1 over the square root. I want to factor out that 4, and I'll have 1 minus x squared over 4, all dx. And then that's going to be 5 halves, because we're taking the square root of the 4. It's still in the denominator, and 1 over 1 minus x halves squared dx. And now I'm ready to just say inverse sine of x over 2 plus c. And my chain rule on inverse sine is going to be a 1/2 times 5 gives me my 5 halves. Okay, I hope that helps.